All right, here we go. We got area of regular polygons. We're going to find the areas using special right triangles. All right, now before we can talk about the formula, we kind of need to know what some of the pieces of the formula mean. So we have this new vocab word. It's called the apothegm. Let me draw it first. What an apothegm is you start from the center and then you go straight down perpendicular to one of your sides right there. So that is called the apothegm of a regular figure. So we can say from the center, you can, well, let's say a line. So a line from the center to one of the sides, and it needs to be perpendicular. Right there. All right, perimeter of a shape. We'll use that in our formula. In perimeter, we can just say that's the distance around. A shape, kind of an informal definition there. Okay, radius is a little bit different. So the radius is from the center, and then you connect it to a vertex. So if I go and draw a radius, that would be one right there. So I'll put a little R there. I'll put an A for the apothegm right there. All right, and notice when you do that, you make a right triangle. All right, when you have a right triangle, we can go and do some of our techniques. We're going to actually use our special right triangles that we've been talking about for the past few days to go and find maybe a piece of that triangle. And then after that, we can go and use this formula up here at the top. Okay. One other thing is the central angle, and I'm going to draw this on another figure. And you're going to say this is the, if we wanted to be kind of formal, I would say it's the angle between maybe like two consecutive radii, I guess. I think that's two eyes or something. Maybe it's one, I don't know. But between two different radiuses, or we actually say radii. So here would be a central angle from the center, and you draw two radiuses right here, and this would be your central angle. And I think for hexagons, it's 60 degrees. All right, we'll talk about how to find it here in just a second, because I think we'll have to do that. All right, so anyways, here's a formula that we can use to find the area of any regular polygon, and it's 1/2 the apothegm times the perimeter. So A is the apothegm, and then P is the perimeter. Right there. All right, and where this comes from is essentially what you want to do here. And let's take this octagon, for example. So you want to find the area of one of these triangles here. All right, we know the area of a triangle is 1/2 base times height. All right, so you're going to do that a bunch of different times there. So you're going to have a ton of these little triangles. And instead of saying one base at a time, if we multiply by the entire perimeter and then times the height or the apothegm right there, and then we do 1/2 of that, we can actually find the area all at once instead of doing a bunch of individual triangles. So that's where it kind of comes from there. So it's really similar to 1/2 base times height, except, or if we wrote it in the same order, 1/2 height times base or whatever, but instead of the base, we use all of the bases combined, or the sum of the bases. So that would be your perimeter, and that's where it comes from there. All right, and we'll do this using some of our special right triangles. So notice on these here, find and label the central angle. So I'm actually going to go and erase some of this here just to talk about how to find your central angle. So remember, you want to draw two radii right next to each other, and then you want to find that angle And the way you do this here is you're just going to go and take 360, because all the way around in a full rotation you have 360 degrees. So you take 360 degrees, and then there would be 8 of these central angles since it's got 8 sides. So we'll say 360 divided by 8, and that comes out as 45 degrees. So 45 degrees, and then that's all you got to do there. Let's see, do we need to do anything else? Label central angle. Nope, that's it. Okay, square. If we draw 2 radiuses, or I'm sorry, radii right there, you do that, 360 divided by 4, that's going to get you 90 degrees. Or you could, I guess, draw a right angle. That's pretty much it there. I mean, you do the same thing for each of these. Hexagon, 360 divided by 6, that'll be 60 degrees there. Okay, what do we got here? Triangle, central angle here. Looks like an obtuse angle there. That's going to be 360 divided by 3. So that'll be 120 degrees. Let's see what else we got. Pentagon, 360 divided by 5. I think that comes out as 72. Yep, 72 degrees. So that's all you got to do there to find the central angle. And we'll kind of use that idea here in a second to make some conjectures about certain types of regular polygons. And then later on in the year, we'll use central angles a little bit more. Okay. Now, when we draw our central angles for certain shapes, and then we also draw our apothem at the same time, we're actually going to make some of those 30, 60, 90s or 45, 45, 90 triangles that we've been talking about for the past few weeks here. So imagine we take a square right here and we draw one of the central angles. We found out that that was 90 degrees. And then essentially what we're going to do here is we're going to draw the apothem going straight down. I'll call that A, I guess. So you have your apothem, here's your radius. So notice here, if you cut that angle in half, that's going to be 45 degrees. Remember, this has got to be perpendicular to one of the sides right there. So this actually makes a 45, 45, 90 triangle. So if you want to go ahead and redraw that triangle a little bit bigger over here, go ahead and do that. So 45, 45, and then 90. And then if you want to label your sides, I guess R and A. And then this right here is like a half of the side. So sometimes we'll use that right there. We'll say as for like a full side and then like half as for the half side right there. Alright, then after that we can, I guess, go and label the apothem, the radius, and the side. We're going to use the ratios that we've been using for the past few days with our special right triangles. So the apothem, that's kind of like our x right there. Our radius is like x root 2, whatever that is, and then the half side is also going to be x. Right there, and that's the ratio between the apothem, the radius, and the half side of a square right there. Alright, and then if we had some of that information, like sometimes they're going to give us the radius of a square. And if we have the radius of the square, we can go and work backwards, find the apothem, and then eventually go find the area of the square. Alright, the formula is not as useful on the squares because we know how to find the area of a square. You just, go side times side, and that usually finds it. So it's not as useful here, but on these triangles and hexagons that we see here in a second, the special right triangles are going to be a little bit more powerful and be able to help us out a little bit more. So we're going to do the same thing that we did right here. We're going to start out with 2 radii. So we said 120 degrees. I'm going to just kind of write this outside because we're about to cut that in half. So if we have 120 degrees, I'm going to cut that in half right there. That means I'm going to have 30 degrees up there at the top. Therefore, this makes, or not 30, how about I do some math correctly, 60 degrees. And then therefore, you have a right angle, so this little angle down here is 60 degrees. So you're going to have a 30, 60, 90 triangle. So I'm going to draw that a little bit bigger. So 30 down here, 60. So your apothem, don't forget, that's the side that's going up and down. So I'm going to put my apothem there. My radius is the diagonal. And then I guess you have your half side down there at the bottom. Okay, just like we've been doing past couple days, we'll go ahead and label our sides here. Remember, your shortest side, we'll call that X. Your longest side, or your hypotenuse, we'll call that 2X. And then, here, let me make that look better. 2X, and then this side here will be X square root 3 right there. And then you can just go and label your ratios here. The apothem was X, the radius was 2X, and then the half side is going to be X squared 3. Okay, and then we'll do the same thing here for the hexagon. It's going to be very similar. When you do your central angle from the previous page, we learned that that was 60 degrees. If I cut that in half right there, you're actually going to have a 30-degree angle. And you got your radius apothem, you got a little half side right here. And then we can go from there. So you have a 30, 60, 90 triangle. Notice the perspectives changed a little bit. It's one of those tall ones. So 30, A, R, here's your half side. So the ratios change just a little bit here. So we'll say that this side, the half side's the X, the apothem will be the X root 3, and then the 2X will be your hypotenuse. So it's a little bit, it's like it's reversed. And there you go. So we use those ratios there, and if we use those ratios, we can find like the different pieces, like sometimes the radius, apothem, or whatever we need to do right there. All right, so that's kind of where it all comes from. You can memorize those. Usually I just redraw the special right triangle, so I don't have to memorize anything, I guess, or memorize less. So like here, you got a 45-degree angle here. What do they tell us? The apothem is 10. Therefore, this half side down here is also going to be 10. So you're going to have X, X, and then X root 2. So that means your radius will be 10 and then square root 2. So I'll go ahead and start putting some of this down. 10 square root of 2. And then this full side, so this, notice here, S, that's representing the full side. Well, if the half side's 10, the other half side's 10, that means the full side is going to be 20. To find the perimeter, you need to do, you got 4 sides, so we'll go 4 times 20. You'll get 80 units. And then the area of this, and there's kind of 2 different ways you can do this, I guess. I think they want us to use the 1/2, the apothem, and then times the perimeter, but you can also just use logic here. If one of the sides is 20, and that means the other side's 20, you'll go 20 times 20, so it should be 400. And we'll go and verify that with our new formula here. So let's see, the apothem started out as 10, so we can go 1/2, 10, and then times the perimeter, which is 80, right there. Okay, so that should just be 5 times 80, which would get you 400 units right there. And I forgot to go back and put my units, so I'll go do that. So radius is in meters, sides in meters, perimeter in meters, area will be meters squared right there. And there you go. So the 1/2 AP is not as useful on the squares because there's, honestly an easier way to find the area of squares, but once we get to these examples down here on the next page, it'll become a little bit more useful on those. So anyways, let's try this one here. Notice the radius is 6 square root of 2. Okay, and so that means, if you know that this is 45, 45, 90, that means that these 2 sides here are going to be 6. So we can say the apothem is 6, the half side is 6, therefore the full side would be 12. What units are we in? I guess they didn't give us units, so we'll just say units, units. Perimeter, so if the side's 12, multiply that by 4. So then that's 48 units. And then the area, we can use the 1/2 AP, or you can just go side times side. So 1/2 times 6, and then times the perimeter, 48, or you can just go 12 times 12. You should get the same thing, 144 units squared. And that's kind of it. I mean, it kind of gets repetitive after that. Sometimes they'll give you different starting information. Zoom in. Just Struggling today here. So yeah, like this one here gives us a perimeter is 40. So to find a side, I just go and do the 40 divided by 4. So that means each side is going to be 10. So therefore a half side will be 5. And once again, 45, 45, 90. So you got x root 2. So x is 5. That means the other x is 5, which means your apothem is 5. Apothem going up and down. Radius would be 5 root 2. The full side was 10. The half side's 5, but the full side's 10. And then, yeah, now we can go and find the area. And that should be 100 once you do that. If you want to go 1/2 AP, 1/2 5, and then times the perimeter, which, oh yeah, they started this out with 40. And 100 units squared, actually, right there. So there you go. Now, once we get to the regular triangles and the regular hexagons, we don't have like a nice way to do the area for these. So we're going to have to use that 1/2 AP. So notice this one here, they give us R is 8 meters. And that's your radius. Remember, you have a 30, 60, 90 triangle. Looks like this one down here at the bottom is a little bit smaller, and so that should be the 30 degrees. And you can go verify that by the triangles we have up there at the top. But yeah, that'll be 30, and then we can go label our ratios. So we'll go and say that this side here is x. We'll have x root 3, and then we'll have 2x for that side. So I'm going to go off to the side, 8 equals 2x, therefore regular x is equal to 4, which will help us get our apothem. Let's go label that. So that's 4, and then if we know x is equal to 4, then this half side will be 4 square root 3. And then we will leave that as part of our answer. I guess we'll have the square root of 3 in there. So the half side, so notice here, you have 4 square root of 3. That means the other half side would be 4 square root of 3. That means the total side would be 8 square root of 3. You would just multiply that by multiply it by 2. Okay, if that's one side, to find the perimeter, there are 3 sides. So I'm going to go 8 squared root of 3 and then times 3. Right, and then that'll be 24. You just multiply the 8 and the 3. So that'd be 24 and then square root of 3. Okay, area of this figure, now we're going to go and use that 1/2, the apothem, so 1/2 times 4, and then times the perimeter 24, and then square root of 3. So I think you're going to get something like 1/2 times 4 is 2, 2 times 24 is 48, and then you don't multiply the square root of 3. Remember, outside numbers with outside numbers, and then inside the radical numbers with the other numbers inside the radical when you're multiplying. And then let's just go back and get our units here. We got meters, meters, and meters squared. Oh, meters, 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 and then meters squared. And then you're good to go. Okay, let's try another one here. They might give us some different information. Oh yeah, so they give us a perimeter to find the side. Let's divide that by 3. So that'd be, I guess, 8. And that's one full side, so you got to be really careful. Some people go a little too quick here. The half side, that means that's 4. So the half side is 4. Let's go label our special right triangle. So that's 30 degrees. You're going to have, this is the x root 3 side, x, and then 2x. Okay, so we will say, and we'll probably need a little bit of room for this, x squared root of 3 equals 4. So we'll have to divide, so that'll be 4 divided by square root of 3. And then we'll also have to rationalize. So this one's going to get kind of messy here. So that'll be 4 square root of 3 over 3. And that is your apothem. 4 square root of 3 over 3. So this one might get interesting here. We'll see. We need to double that to get the radius. And I don't know if any of you guys picked up on this. The radius you don't actually use for the formula. The only reason the radius is useful is sometimes they'll start us out with the radius. So we don't actually use it there. So 8 squared root of 3 over regular 3. Apothem was 4 square root of 3 over 3. And then now we can use the 1/2 AP formula for the area. So we'll go 1/2. The apothem was 4 square root of 3 over 3. And then the perimeter was 24. So it's kind of like having 24 over 1. So you can use, different techniques with your with the diagonals, like canceling out and reducing your fraction here. So like you can like divide the 24 and the 3. If you want to cancel those out, that'd be like 8. And then you got like 1 and 2 right there. So I think that's going to be 16 once we're done. 16 square root of 3. Now I'm just going to double check that real quick. So times 24 and then divide by 6. Yep, 16. So that'd be 16 square root of 3. And then we go back and put our units. We got meters, 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 and meters squared. So anyways, there you go. That one a little bit more complicated. They all don't come out that weird with some of the numbers, but sometimes they do. So anyways, here notice you got the side is 6. That's a full side. I'm about to mess that up there. So then the half side is 3. Once again, you got a 30, 60, 90 triangle. And then we'll say this side's the x root 3, x, and then 2x. Okay, and then we can go and find everything from here. So notice x square root 3, that is equal to regular 3. Some of you guys know a couple little shortcuts to speed this process up, but I'm going to go ahead and write it all the way out. So divide by square root of 3, rationalize. So that means we need to multiply top and bottom by square root of 3 over square root of 3. And then notice here, this actually kind of cleans up and reduces. Those will cancel each other out, and then you're just left with square root of 3. And that is your apothem right there. There you go, square root of 3 for the apothem. You need to double that for the radius, so that would be 2 square root of 3. Perimeter, we actually could have found the perimeter from the very beginning. A side is 6. Therefore, the perimeter would be 18 once you add those all the way up. And then area will go 1/2 AP. So that'd be 1/2 the apothem, which is just square root of 3. So you really can't do much with that. And then the perimeter was 18. And remember, you can multiply things in any order. So I'm going to do half of 18 and then multiply that by square root of 3. So that'd be just 9 and then with the square root of 3 attached to it, kind of like that. And that would be your area. And most of these, we're going to leave these in simplest radical form, since that would be the most exact. Okay, so now we're almost done here. We have a couple of other shapes here. We got the hexagons. These will be kind of similar to the triangles as far as how they turn out, because you're going to have a bunch of 30, 60, 90 triangles. You'll have a central angle of 60 degrees, and remember, you bisect that. Then we can go from there. Now notice here you got a side length, it's 10, so that means a half side will be 5, and then if we go and label our ratios, a root 3, or whatever variable you use. So I was using a one day and then x the other day. So x root 3, and then 2x, or a root 3, and 2a, doesn't matter. So anyways, x is equal to 5, therefore your apothem going up and down right here, that'd be 5 and then square root of 3. To get the hypotenuse, you want to double that. So that'd be 2 times 5, or 10. Okay, perimeter, well, a side was 10, so we want to go, 10 times 6, since there are 6 sides. So that'd be 60. And then area, we'll go 1/2 apothem times perimeter. So 1/2, I guess 5 square root of 3, and then times 60. And remember, you can multiply in any order, so I'm going to go half of 60 first, which is 30, and then times 5 square root of 3. So 5 times 30 is 150. So we'll say 150 square root of 3, and then we'll go back and put my units. Meters, 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 meters squared. Okay, couple more. I'll speed it up here just a little bit. 30 degrees, x root 3, 2x, and what are they giving us here? Radius is 12. So the radius, the 2x side is 12. Therefore, your x side right there, your half side, is actually going to be 6. And if your half side is 6, the other half side is 6, therefore the whole side is also 12. So actually with the hexagon's radius, it will be the same thing as the side lengths. The apothem, that's going up and down, that's when you plug it back in, 6, and then square root 3 for the apothem. Perimeter, what was it, 12? So we'll go 12 times 6, that'll be 72. And then the area, 1/2 the apothem times perimeter. 1/2, 6 square root of 3, and then times 72. And I'm just going to use my calculator for that. Essentially, that's just 3 times 72, and I got 216. And then make sure you attach on the square root of 3 right there. What is that? Meters, 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 meters squared. Alright, last one here. Perimeter 54. So we need to go 54 divided by 6, I guess, to get that. And that'll be 9 for each side. So I guess this one's going to kind of be annoying, because that means a half side is going to be 4.5. So we're going to kind of have decimals going on, I guess. Alright, so what do we got here? We got x, x root 3, and then 2x. So side we said was 9. The apothem is going to be, well, actually, yeah, the half side, well, yeah, we don't have a spot for the half side. The half side is 4.5. So then the apothem going up and down is 4.5 square root 3 for that side. And the radius, you want to double the 4.5 so you get back to 9. And then we can go and do the area. What do we have? 1/2, I guess 54. Well, technically that's out of order, but it doesn't really matter. Apothem, what was that? 4.5. And then square root 3. And then times, oh yeah, 54. So I'm not sure if that's going to come out super clean here, so I'm just going to use my calculator. 0.5 times 4.5 and then times 54. Oh, and then I typed it in wrong. 0.5 times 4.5. Okay, and apparently that is 121.5 and then square root 3 at the end, if I typed that in correctly, which it appears I did. And that's in centimeters. Centimeters, 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 centimeters squared. That's all she wrote there. Alright. So once again, all boils down to your special right triangles. Make sure you know your ratios, then you're good to go.